Now this morning, joining us by phone, we have Giuseppe Torri, who is an assistant professor at the University of Hawaii in the Atmospheric Sciences Department, to talk all about Hurricane Douglas and what we're anticipating in the next coming hours. Good morning, Professor Torri.
Good morning, Kelly. Good morning to all the viewers who are watching.
All right, so let's talk about the system. Where are we at, and what is the most recent update from the Hurricane Center?
So I think there have been a number of updates throughout the night, and I think the last one should probably be out about now. I think the main story, or at least the main points that I can see, the main interesting points are that the system is approaching the islands, is now pretty close to a lot of the islands, to Maui, and it's approaching Oahu as well. So it is still continuing on a west to northwest track. What I think is interesting is that the storm is weakening as it was forecast to. But probably not weakening as quickly as we would hope that it would weaken, and this is partly due to the fact that the storm is now over relatively warm waters, and it is moving over warmer and warmer waters, and wind shear is starting to pick up and help, but the wind shear is mostly confined to high altitude, and so this is affecting the storm a little bit, but probably not as much as we would want.
And let's talk about that. Let's talk about, because you mentioned the sea surface temperatures, you mentioned the wind shear. How exactly does that impact the hurricane itself? First, let's start with sea surface temperatures, because initially, of course, as the system formed in the eastern Pacific, we saw it strengthen to a Cat 4 storm. It was in warmer waters, popped into cooler waters when it entered the Central Pacific. Now we're seeing this back in warmer waters. Why does that impact the system?
So the system, hurricanes in general, derive most of their energy from the ocean water. And the warmer the water, the better it is for the ocean, because this is literally what is driving the hurricane, in a sense, the main source of the main fuel, if you will. Okay, and
oh no, continue.
So there's a threshold of approximately 80 Fahrenheit degrees. And waters warmer than 80 Fahrenheit degrees tend to help the storm, and waters colder than 80 degrees tend to weaken the storm. Now, we happen to be more or less at a transition zone. And so waters here are roughly around 80 degrees. Mm-hmm. And so even slight variations in the path of the storm, can make a difference in whether the storm is going to weaken or it's going to strengthen. And as the storm passed over warmer waters, clearly it increased in category, went up to Category 4. We were hoping that that the storm would be pulled a little bit more northward so that it would go over colder waters, but it hasn't been quite the case.
Right. And okay, so again, warmer waters, it's great for the system to continue to either maintain its strength or to even increase in strength. But now let's talk about wind shear, because when we talk about wind shear, this is typically what we have in place across the islands that can sometimes protect us, right? We usually do see this impact the hurricane in a positive way for us. It weakens the system. Talk about wind shear. Let's talk about how this would break up a system, and also why that's not necessarily happening right now.
Yeah, so I think that we have seen in the past wind shear being a good friend for us. I seem to remember that for Hurricane Lane, it really made a big difference in the next day when the hurricane was approaching. We saw the wind shear pick up, and that more or less destroyed the storm or weakened it considerably in over a day. And one of the reasons, or the main reason actually, why the wind shear is not good for the storm is that these types of systems, meaning tropical cycles, are highly organized systems, and they need a lot of ingredients and a lot of things to line up perfectly in order to continue along their track and to continue to be powerful storms. Wind shear is, just for those who are not sort of expert in the field, wind shear is the difference between the wind speed and the wind direction across different altitudes.
Right.
And so when we have wind shear, we have here in Hawaii, we tend to have low-level winds that are blowing from the northeast to the southwest and high-level winds that blow in the other direction. So this essentially tilts the hurricane, and tilting the hurricane is one way to destroy it, because it impacts the organization that the storm needs to continue. Now, usually because of trade winds, we do have this consistent wind shear. Although trade winds aren't always here, there are variations throughout the year, mainly because the high pressure ridge that drives the trade winds is kind of stable, but it moves around and it changes intensity. So now we are seeing this ridge coming to help us, but unfortunately the help is mostly confined to the upper layers of the atmosphere. So when we look at the profile of the winds, for example, we see from 30,000 feet above, we see pretty strong shear that is essentially blowing over the hurricane like a hot soup. But then altitudes below that, which is where a lot of the storm is, and which is where a lot of the intense regions of the storm are, the shear is not impacting those areas yet.
And why exactly is that? What is driving, I guess, the mid-level shear to be weaker than what we may typically see during this time? So
this has to do essentially with the large scale, if you will, with how the planet organizes the circulation in the atmosphere. So this is something that goes beyond the scales of Hawaii, and it's influenced by how much the continents are warming during summer. It's influenced by, what's happening in Japan, for example, with the storm track and all that. So it's influenced really by the large scale circulation. And it's not that we couldn't predict that, or, it's not that we didn't necessarily know what was going on. It's just that because these are such big systems, often it's really hard to predict exactly how they will change in the finer scale. I mean, here we're talking about, maybe a difference of a few tens of miles that could make a difference for how the storm is going to be impacted. And so, I just wanted to give some credit to people who made forecasts, because it is essentially pretty hard to predict often changes on such a small scale.
Definitely. And with that said, I mean, with, this being so, I guess, sensitive, right? You can see such changes. I mean, the Central Pacific Hurricane Center's forecasts the last few days, but even for the last week, have been actually pretty spot on with this system. Okay, now we talked wind shear, the unfortunately slightly weak wind shear, as well as the very warm sea surface temperatures. So that's what's gotten the system to where it's at. That's why it's at the strength that it's at. We've seen these winds sustained at about 90 miles an hour at the center of the storm overnight. But what now does that mean for us? We have a Category 1 hurricane near the state. What should we be expecting in the next few hours? What are the impacts that typically a Category 1 hurricane brings?
So what should we expect? I think that I would say the jury is still out a little bit. I would say it's quite likely that we'll see an increase in rainfall and an increase in wind speeds over the islands. I think this is a fairly safe bet to make, given that the hurricane is getting closer, particularly to Maui and Oahu. Now, as to the impacts that these storms can have, Category 1 may not seem like a big deal because, it's just a simple Category 1, but they can have pretty devastating effects. And I think it's a little bit like with hurricanes, where you establish scales to determine the magnitude of an earthquake, but the impact that it has, the severity of the consequences of these big events often depend on the infrastructure, often depend on where exactly or how exactly the storm is going to manifest itself over the islands. So, for example, The storm is approaching Oahu, and I think it's safe to say that the windward side will probably see a lot of rainfall, probably see a lot of wind. But anyone who's been around the islands has seen that the topography of the island is very complex.
Yes.
And there are sometimes very large valleys, sometimes very narrow valleys. And how exactly the wind interacts with these valleys is a non-trivial problem. And so, you know, in certain valleys, maybe the interaction would channel some really strong downslope winds and, you know, create a lot of damage. In some other valleys, this may not be the case. So I think it's hard to pinpoint exactly what the consequences or, you know, the real impacts would be, other than saying that probably heavy rainfall and strong winds is what should be expected on the islands. I think this is safe. Other than that, it's a little hard at the moment to predict exactly what the consequences would be.
Yes, and right now we are looking at some of the forecast models, and this is a good example of why exactly that is hard to predict, because at the same time, obviously, we're hoping for the best. We're hoping that this does go on a more northern track, but the forecast model is not in complete agreement. We're looking at a couple of those forecast models that have the system passing directly over Oahu and directly over Kauai, others just to the south of that, whereas a few more have it passing directly to the north. So exactly how sensitive is the storm? Because we hear that, you know, any slight change in the forecast track, if it does go a little bit more to the north or if it does push further to the south, that could mean very drastic differences when it comes to the impacts.
Yeah, and I think that this question also is an interesting question, and it kind of, I think the real answer is that it depends on what you, so when you talk about the sensitivity of the storm, I think it kind of depends on what you would call a change in the storm. So the storm is sensitive, certainly, to environmental conditions. What we do care about here is changes of even a few miles that could make a big difference. But changes a few miles, you know, may be a very small change or maybe a very big change for the hurricane. So these systems are effectively really sensitive to environmental conditions. But how exactly then these sort of the influences translate on the hurricane is kind of hard to predict, precisely because small changes may not be a lot for the storm, but they may make a lot of difference for us here on the ground.
Definitely. And again, these are the impacts that we're going to be seeing in the next couple of hours. We're expecting the very heavy rainfall, the very strong winds. Again, a hurricane warning was just issued for Maui County. And then we have, of course, the tropical storm warning posted for Hawaii Island. These impacts we're expecting to see ramping up in the next couple of hours. And Professor, we are actually here. I'm about to pull up the radar right now. I don't know if you've seen what's happening currently out there with the system, but it looks like we actually have a pretty nice look at the very center of the storm. It looks like the eye just to the northeast of Kahului. And it looks like, although we are seeing some widespread showers, the heaviest of the showers haven't reached the state just yet. So when Big Island and when Maui County are seeing these showers, this isn't the worst that we're expecting yet, right? We are expecting some more changes to be coming through in the next few hours.
Yeah, absolutely. And I wanted to say one thing about the eye of the storm. Yes, I think it is pretty impressive that now the eye can be seen on the radar, and it's I mean, I think as a scientist, I'm fascinated, but at the same time, I'm kind of horrified as a person who lives here. So, you know, I do hope that this doesn't mean, you know, anything too bad for us. One interesting thing is that the wind shear that we talked about earlier, so the winds blowing from the south to the north at high altitudes, they haven't tilted the storm as much as we wanted, but they have tilted the storm a little bit. And so there is a slight misalignment between sort of the eye at the low levels and the eye at the eye level, at the high levels. And so when you look at, for example, satellite images, the eye that you see from the satellite it may actually be further away from the real eye that we get to see here over ground. So I just wanted to sort of caution people when they look at satellite pictures, for example, to not be tricked by the slight misalignment. And yeah, absolutely. I think the closer you get to the eye of the storm, the more intense the rainfall is. Now, rainfall in hurricanes tend to be concentrated in regions that we call rain bands. Mm-hmm. And really, really large storms have many rain bands, and they can bring rain hundreds of miles away from the eye. But what all the storms have, and I think this is what we're beginning to see from the radar, are so-called primary rain bands, and this is where a lot of the intense rainfall is concentrated, and it's precisely around the eye. So as the eye gets closer to the islands, we're probably going to see an increase in rainfall. I think this is probably a safe bet. Also, the interaction of relatively moist wind at the surface and the topography is likely going to create even more precipitation as these storms approach the islands.
Right, and again, this is all just going to be happening within the next couple of hours. We're starting to see the rainfall ramp up. Again, an impressive image that we're looking at actually right now, both the satellite and the radar, which again, in those last couple of frames, we are seeing a very well-defined eye wall. So thank you so much, Professor, for joining us this morning, for explaining so much about this system. Do you have any last words for us?
I just want to, caution everybody to take this very seriously. Be careful, stay safe, and good luck to everybody. And thank you so much for having me.
Of course. Thank you so much for joining us. All right, stay safe out there. All right, and again, that was an assistant professor from the University of Hawaii, Professor Tori.